Okay, so this video is going to be incredibly brief because this is something that we touch on when we get into every single kind of function. And to get more specific, that of course is transformations. So, how do transformations work with exponential functions? So, here is your standard form uh, exponential function, right? You can already probably guess what A does. A does vertical stretch or shrink. Okay. When A is greater than 1, we have stretch. Okay. And when A is, uh, here, let me do this. Now that's going to be confusing if I write it that way. When A is in between 0 and 1, it's the simplest way to put it to not confuse anybody, right? This, of course, means shrink. Okay. So both of these come from A, right? B, we talked about in the previous video. This is our growth or decay factor. Okay, this is our growth or decay factor, right? And it's growth when B is greater than 1, right? And it is decay. It's decay when B is less than 1. Okay, and here, I should get even more specific because sometimes these numbers might be negative. Okay, that's not really what's important. We should say the magnitude of B, right? So whether it's positive or negative doesn't matter. The absolute value or magnitude of B is what actually does matter. Okay, so that's uh, that is what B is representing, right? Is either growth or decay. Okay, and then, and actually, I shouldn't get too far ahead of myself. Let's back up to stretches and shrinks, right? And let's remember that if A is negative, right, this means we're being reflected across the x-axis. Oops. Okay. So, and again, we know that. Not anything new. Okay. C, right, is going to be our horizontal shift. So that means either right or left. Okay. And D, like starting to run out of colors here. I'll just use red, screw it. D is our vertical shift, right? And of course, that means up or down. Okay, so let's look at really quickly the geometry to all this. And I clicked on the wrong thing. Gosh dang it. I already have it pulled up. Okay, so here we see our standard form, right? So when A is 1, we're just going to leave A1 for now. But let's say our exponential base is a 3, right? Well, we see exponential growth. Okay, plain as day. Okay, when C is 0, right? No big deal. But when C is, I don't know, moved around, right? We see that we're shifting right or left. Okay, and what about D? Well, we know D is going to make us go up or down. Okay, and then we see if A is increased, right? If A is greater than 1, we have vertical stretch. If A is a fraction, like zero point 0.3, we have vertical shrink. Okay, however, when A is negative, right, we get reflected across the x-axis. Okay, but we still see, right, this would still, just because A is negative, that doesn't really change anything. Okay, if A is negative, that just means we're still having exponential growth. It just means we're going the other way. We would have like negative growth. Okay, and then for B, it's kind of sort of likewise. Okay, when we have negatives, right, it gets really crazy. Okay, so we'll get into that later. Okay, but you can see Desmos is kind of losing its mind when I put a negative number being raised. Okay, because then you have alternating powers, right? And we'll get into that later. We kind of saw what alternating series look like when we did sigma notation, but for all intents and purposes, we're going to assume, like I showed you a second ago, we're going to assume that we're talking about just the magnitude of b, and that b is going to always just be assumed to be positive. Okay. Okay, so that does it for the transformations of exponential functions. If you have any questions over anything, come find me or shoot me an email. Goodbye.